Woohoo! Welcome back to math. And we are on interpreting linear expressions. And so last lesson was on identifying terms, coefficients, factors, and constants. And now we're going to take it a step further and we're going to start to really look a little bit deeper into these expressions. So algebraic expressions are used to describe various situations and they contain variables. So remember, variables are letters. It's important to understand how each term of an expression works. Remember, a term is separated by a plus or a minus sign. So 4x plus 3x minus 4. There are 1, 2, 3 terms in that expression. And when you change the value of your variable, it changes the value of your whole expression. And these expressions are used every single day to model lots and lots and lots of different things in life. Okay, so key concepts. Now remember, this is the part of your note packet, and in your packet, this is U1-19. It's the bottom right. It's got a little black rectangle that says U1-19. This is the part of your note packet that you're going to annotate. You're going to highlight, underline, write notes off to the side, questions off to the side, like what kinds of things might you wonder about this? What questions do you have for the lesson? So don't forget to also do your annotating as you go along, and pause me as well so that you can make sure that you're getting everything that you need. So the key concepts. If a situation is described verbally, it's often necessary to first translate each expression into an algebraic expression. In other words, if there's a paragraph and it's written in words with some numbers spread throughout, you're going to need to figure out what the algebraic expression is. An algebraic expression is just numbers. Remember, does not have an equal sign. An equation has an equal sign. And then as your variables change, your x's, your y's, whatever your letters are, it's important to understand that other things are going to change, but not your constants. The constant is always going to remain the same. And your constant, this guy, so if we had 4x plus 3, positive 3 is the constant, meaning it does not have a variable attached to it. It does not have a letter. So the constant's never ever going to change no matter what we plug in for x. If we plug 2 in for x, that means 4 times 2, 3 is still going to be 3. So similarly, changing the value of a constant won't change the terms containing variables. So changing the number 3 to a number 4 is not going to do anything to the beginning part of the expression. And it's also super important to follow your order of operations, and as this is going to help you guide your awareness and understanding of each term. So remember, order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. Common errors and misconceptions with this is incorrectly translating given verbal expressions. So when you're given a paragraph and then you have to put it into numbers, it's really easy to make something a positive or a negative that should be the opposite, or to have them in the wrong order. We're going to do lots of practice, so hopefully you will not incorrectly translate. Okay, so in your packet, we're going to move to the example. And the example number 1, we're going to save for class. So we're going to do example number 1 about the new car losing an average value of $1,800 per year. And we are going to skip to example number 2. And I forgot to mention, in your note packet, the examples come before the annotations, which we just did. So it just got printed incorrectly. So you're going to go to U1, Unit 1, page 21, the little black rectangle at the bottom. So we're going to save example 1 for class and start off on example 2. So example 2, to calculate the perimeter of an isosceles triangle, Before we go any further, perimeter. Okay, I'm just drawing freehand, so you got to bear with me, okay? Perimeter is the outside, when you count up the outside, okay? It doesn't have anything to do with the inside. The expression 2s plus b is used, where s represents the length of the two congruent sides, so that would be s, and b represents the length of the base. B is the base. What effect, if any, does increasing the length of the congruent sides have on the entire expression? Okay, so we're going to look back at the expression 2s plus b and changing only the length of the congruent sides s, so this, does not impact the length of the base b, because b is a separate term and it's a constant. So no matter what happens to the length, the s, b is not going to be impacted. All right, let's move along. If the value of the congruent sides s is increased, so if we increase s, let's say to 2, then that's going to be 4. If we increase it to 8, that'll be 16. So the product of 2s will also increase. So anytime we increase s, the whole product is going to increase. How about if we decrease s? What if it's -2 or -4? Then the value of 2s will also decrease. If the value of s is changed, the result of the change in the terms is a doubling of the change in s, while b stays the same. So we had 2s. So that's where doubling of the change in s comes from the 2, because 2 means doubling. And it was plus b. b is on its own, so b stays the same. So what we just did, we didn't solve anything. We're just learning how to really look at an expression and pick it apart, so that when we get to solving in a couple of lessons, we really understand what we're doing. All right, the third and final example for this lesson, this is a shorter lesson, is about money being deposited in a bank account, and it earns interest on the initial amount deposited. And this is real stuff. These formulas, you don't necessarily use these when you go to your bank and when you're calculating the amount of money you have in your bank, but this is the stuff that's used behind the scenes. And so it's really important to understand what is happening so that you can understand and how to understand and learn how to better manage your money moving forward in life. Okay, so we're depositing money in a bank account that earns interest on the initial amount deposited, as well as interest earned as time passes. Okay, so we've just said a couple of things. It earns interest on the initial amount and as well as any interest earned as time passes. This compound interest can be described by the expression P parenthesis 1 plus r parenthesis exponent n, where P represents the initial amount deposited, r is the interest rate, n is the number of months that pass. The question is asking, how does a change in each variable affect the value of the expression? So we're not actually going to be solving anything. We're just going to look and see, if we change P, what happens to the whole thing? If we change R, what happens? If we change N, what happens? Notice it says change in each variable. The number 1 is not a variable, so we're not going to mess with number 1. Number 1's a constant. All right, so here we go. The expression is made up of one term containing the factors P and 1 plus R to the nth power. Changing the value of P does not change the value of the factor 1 plus R to the nth, but it will change the value of the expression by a factor of P. So in other words, the change in P will multiply by the result of this. So whatever this is, if we change P from 1 to 2 to 16, whatever we change P to, it's going to multiply by that. Similarly, changing R changes the base of the exponent, but does not change the value of P. So we've got P 1 plus r to the nth power. So changing r changes the base of the exponent, okay? So the base, this is the exponent. This thing right here is the base of the exponent. If we had 2 squared, 2 would be the base, and this little 2 is the exponent. I'm writing with my finger on the screen, so there we have beautiful handwriting. So r changes the base, but it does not have anything to do with p. P is a constant, it's not changing. Changing n, again, here we go. We've got p1 plus r to the nth power. Changing n changes the number of times that the base will be multiplied by itself, but it does not change p.